Hi students, how are you? Today we're going to see in this video types of growth, survival strategies, and survivorship curves. Let's go to it. Now, the first thing you need to remember is that we are going to have two types of growth. The first one is known as exponential growth. It goes or it belongs with an J-shaped curve. What does it mean? Okay, so if you see the drawing or the image in here, we are going to have a constant or a very low population size that then dramatically goes exponentially up, increasing the number of the population size. That's why we call it an exponential or a J-shaped curve. Then the other type of growth will be the logistic or the S-shaped curve. Type of growth, logistic. Type of curve, S-shaped curve. Now, if you can see, this type of curve is quite the same as the exponential at the beginning of the process. We're going to have a very low or slowly growth at the beginning. Then we have the exponential phase. But when the population is almost reaching the carrying capacity, population size will start to decrease or to stabilize. Now, these populations tend to be near the carrying capacity always, maintaining high numbers and also allowing organisms to acquire their nutrients and the resources they need because they are this carrying capacity, near carrying capacity. Now, another thing we need to see is a type of growth that we call as boom and boost cycle. Now, when we see this type of graph, we can see a rapid growth or an exponential growth type of the J curve at the beginning. Then you can see here the population overgoing or passing the carrying capacity, which is the maximum amount of organisms that the environment can hold. And then because of this increased biotic potential, the organisms are going to have more babies and they're going to have a higher population size. Now, because of this population overgoing the carrying capacity, finishing with the resources that naturally the environment has, the population is going to start to decrease very rapidly. That's why we have this type of curve going down. Now, what I want you to focus your attention in is in the level of the population in this section or in this period. Now, the population will never be the same as in the beginning of the growth cycle. Why? Remember that this population exceed the carrying capacity. They finish with the resources that were naturally in the environment. So they will never recover as fully as at the beginning of the process. Which examples of populations do we have for boom and boost cycle growth? You're seeing here an algal bloom, which is a lot of algae in the water, probably because of a lot of nutrients in the water. It could be by pollution. And when they have a lot of nutrients, they will have more resources than naturally, so they can have an exponential growth. But once they finish with these resources, the first thing that they will finish will be the oxygen, and then this population of algae and other populations as well, like fish, that depends on the oxygen, they will start to decrease. So that's why we call it a boom and a boost cycle. Another topic that we need to see today is the reproductive strategies. You need to remember that we have two types of reproductive strategies. The first one is the R strategy. It is related with the J-shaped curve or the exponential type of growth. Now, this R strategy belongs to organisms that they are small in body frame. They have a lot of younglings or a lot of organisms and they reproduce being very young. Then they're not going to have parental care. And why do they do that? Why do they have a lot of babies and they don't take care of them? Because they need to ensure that because of having a lot of babies, at least some of them can survive. Then we have the next type of strategy, which is the opposite from the R strategy. They're going to be very big organisms with long mature time or mature periods. They're going to have babies later in life. They're going to have a fewer offsprings in comparison with the R strategy. but these offspring will be high quality. Why? Because they take care of them. They're going to do whatever they can to ensure that the offspring survives. Then finally, we're going to have survivorship curves. Because of some of the characteristics of a population, we can have these three types of curves, and they have different characteristics and different names. The first one is late loss survivorship curve. What does it mean? They're going to have very low death rate at the beginning of the period of life or the lifespan. They're going to have low death rates, which means that they are going to survive being babies, being juveniles, being young adults. They're going to have low death rate. They're going to survive a lot. But when they reach old age, they are going to start dying or to have higher death rates. This is the first type of curve, late loss curve. Then we have constant loss curve or survivorship curve, which means, like the name suggested, they're going to have the exactly same possibilities of dying in any of the life periods of this organism. They can die being very young or being juvenile or being adults. They have the same possibility. And finally, we have the third type of curve known as early loss curve, which means that they are the same. Well, they are going to die a lot being very young, and then when they reach maturity, they're going to be more, or they're going to survive more. So now for remembering these three concepts or these three ideas, I'm going to present you this image. You can pause the video and try to solve it out, but if you can't, this is the summary. So for exponential growth, we're going to have J-shaped curve. We're going to have an R strategy. Body size of the organisms that have generally exponential curve, they're going to be smaller. They're going to have a lot of offspring with lower survival rates and generally no parental care. For the case of logistic growth, we will have the opposite. The curve that they show will be S curve with type of a strategy, K survival strategy, bigger organisms, fewer offspring with higher survival rate, and parental care. So I hope you enjoyed this video. I hope it is useful for you, and we are going to see ourselves in another video. See you soon.